Okay, so we're looking at a specific triangle x, y, z, right? And we're going to have to set this up. So we're going to quickly just kind of put together a triangle here. Now it's not going to be perfectly to scale. We're just going to kind of draw it out and put our sides on it. Okay. We're going to name it. We'll call this x, y, and z. Okay. So we'll label our angles first. Angle x is what degree?
Angle x is 90.
So actually this means this thing here is a 90-degree angle. Okay, so that's a 90-degree angle. Angle y is 60.
60.
Okay, and then side xz, which one is that talking about?
That side.
Yeah, opposite of the y. Xz here is 73 meters. What's the question asking?
Find y, z.
Find, where does it say that? Oh, find yz. Perfect. Okay, so which side is yz in this case?
That side.
This side here. Perfect. So we're looking for this side here, okay, of this triangle. And there's several rules we can use, okay? You have a lot of laws here, a lot of formulas. Sine law and cosine law, as long as you have the letters to set them up, they'll always work. Doesn't matter what triangle, they will solve it. The only thing is these ones here also work, but only with 90-degree triangles, okay? It has to be a right angle triangle. The key here is a sine law and cosine law will still work, but they're a lot more complicated, where this one is far easier, okay? So, like we were saying before, these work with right angle triangles, and they're far easier, these primary trig ratios, than using sine law and cosine law. So since we have a right angle triangle, we're going to use one of those, okay? Now, what we do have is we have this angle here, which is 60 degrees. So depending on our sine, cosine, and tangent ratios, you ever heard them referred to as SOHCAHTOA?
Yeah.
Yeah. We got to figure out which one to use. Okay, so we got to talk about, first of all, what side of the triangle we're trying to find in reference to this angle. So according to this angle, what side of this triangle would this be considered? Would it be the opposite side, the hypotenuse, or the adjacent?
Opposite.
The opposite will be straight across from here.
Oh, adjacent.
Ah, that's right. So this will be the adjacent side. Which side is always going to be the hypotenuse?
The longest side.
The longest side, right? Opposite of 90 degrees will always be the hypotenuse. So we know that 73 is our opposite side. So I'm going to call that my opposite. And this side here is the adjacent. So if I have an angle and I'm working with opposite and adjacent, which of these three ratios do I want to use? Which one of these three deals with opposite and adjacent?
The 10.
10, that's right. 10 deals with opposite over adjacent. So we're going to deal with the tangent ratio. So what it says is tan theta equals, and we'll just put O over A for opposite over adjacent. Now theta refers to the angle, so tangent, our angle was 60, right? Tangent 60 is equal to our opposite side, 73. And our adjacent side is what we're trying to find, so we're going to call that our x. Okay, we'll call that x in this equation. So now that we have that, we need to isolate for x. Okay, so in order to isolate for x, I got to bring x, first of all, I want to get rid of this fraction. I want to bring it to the other side. When I bring it to the other side, what operation do I have to use? Since this says 73, what's that mean when it's a fraction? 73 divided by x?
Yeah.
So when I bring x over, what operation do I have to use?
Division.
Well, what would be opposite of
Oh.
division? Yeah, that's right. So we have x times tangent 60 is equal to 73. Okay? And again, I'm trying to get x by itself. So now I need to move what to the other side?
Yeah.
Tan 60. So to move tan 60 to the other side, what operation would I use?
Multiplication.
Well, this,
Division.
yeah, because that means multiplication, we're going to have to divide. So we're now going to get x is equal to 73 And then this is where we get our divided by tan 60, right? So now what we can do from here is plug this into our calculator to solve this question. Now I'm going to find tan 60 because I have an older calculator. You may be able to do this all in one step. So 60 tan 1.732 0. Okay. All right. It's always good to round to several decimal places. So we have 1.732 0. So 4 decimal places is good. Then x is equal to 73. Let's clear everything. 73 divided by 1.732 and, well, the 0 is equal to 42.1, and we can round that to 5. Okay, so we don't know what decimal place they want us to round here. We'll go back up. This side is 42.15 meters in length, which is approximately 42 meters in length. We're not sure which one she wants, but we can keep it moving. Okay. All right, next question, 127 asks us the angle of elevation from a spot 5.5 meters from the base of a tree is 50 degrees. Find the height of the tree. Okay, so let's kind of draw a diagram of what they're talking about here. We got some tree, okay, and here's our person. He is 5.5 meters away from the tree. Okay. Now the angle of elevation, it deals with, this is what we're talking about, elevation. Elevation talks about, and we'll use always a horizontal line. Okay. Elevation means going up from that horizontal line. So this is angle of elevation. Okay. Angle of elevation. Okay, going up from that horizontal line. I'm going to move these words over. And then with that same horizontal line, there's something called an angle of depression. So if we had the same horizontal line, we'd be talking about a line going down from there. Okay, these are your options. It always has to be from a horizontal line. Okay, that's the angle of depression, which is important to note. You know the difference between these two. Okay, angle of elevation, angle of depression. Always talking about the horizontal line. That's the important part here. We always draw our angle of elevation or depression from a horizontal line. So since we got to draw an angle of elevation, we're clearly going to draw an angle up to the top of the tree. The angle of elevation here is 50 degrees, they said. They want us to find the height of this tree. So the height of this tree, we're talking about from here down to here. Oops, that should be straight. From here down to here. Okay? So we can now kind of redraw our triangle here without our people in our tree and kind of plot our points in. What kind of triangle are we dealing with?
Right angle.
That's right. There's going to be a right angle triangle. We know that this part of the triangle here is 5.5 meters. And our angle of elevation is 50 degrees. They want the height, which means they're referring to this part of the triangle. So since they're looking for the height, we'll call that side x. And again, we've got to figure out which of the ratios we're going to use. So let's talk about, according to our angle, what sides we have. 5.5 is considered what side of the triangle to that angle? If it's touching it.
Bottom.
There's the three terms are opposite, adjacent, and hypotenuse. So what would opposite be?
Would it be tan?
Yeah, we're going to be using tan because the opposite side will be x. Okay, it's important. We have to figure out how to name a triangle. So from that angle, this would be opposite. Okay, and this here would be our adjacent. So again, we're working with tangent. So tan, I'm just going to put it right in, tan 50 is equal to the opposite is our x, the adjacent is 5.5. Okay? Now we're trying to isolate x. So what do I got to move to the other side to get x by itself?
to divide. No, multiply.
Multiply. What do I have to multiply?
The x by 50.
No, we're trying to isolate x. So I want x to be
Sorry.
by itself.
5.5.
Yeah. So let's move that 5.5 over, right? So when I move 5.5 over, because this is a division sign, okay, because that's division, we got to use multiplication on the other side. So we get 5.5 multiplied by tan 50 is equal to x. Okay. So now let's type that in our calculator. We can do that in one shot. Tan 50. This is that number, and I'm just going to multiply by 5.5. There we go. So the height of the tree is apparently 6.55, we'll say, meters. So when we go back up, the height of this tree, pretty tall tree, 6.55 meters in height. We just figured that out. Okay? Similarities, we use tangent for both, but we just had to rearrange the formula two different ways, that's all. Okay, question 127. Oh, I think I said that was the last one. Okay, so we got our lighthouse here, okay, and it shines some kind of light out. There's our lighthouse, okay? So it's shining some kind of light. They've told us that we're trying to find the distance of the boat from the lighthouse, okay? So that's our dotted line here. That's what we have here. This is the distance of the boat from the lighthouse. It also says the lighthouse is how tall?
25 meters.
All right, so we know that this lighthouse from top to bottom here is 25 meters. Okay, so we have a 25-meter lighthouse. And does it tell us any angles?
No, it's 18 degrees.
And what do they call that angle?
Angle of depression.
Angle of depression from where?
From the boat to the lighthouse.
Yeah, does it say from the top of it? Angle of depression of a boat from the top of the lighthouse. That's what's important. So our top of our lighthouse is right here. Now remember we said a angle of depression has to come from what kind of line? A specific type of line it has to come from. Talked about on the other page. Starts with an H.
Adjacent. No, it's
That's okay. Hold on.
oh, horizontal.
Horizontal, good. So we have to draw another horizontal line. Actually, I'm going to draw it in dark here. We have to draw a horizontal line here, okay? Our angle of depression to the boat, this is what it's telling us, angle of depression to the boat goes down there. So they're actually talking about this angle here. This is our angle of depression. It's 18 degrees, okay? But that's not inside of our triangle. The triangle we're working with, and I'll highlight it in green here, okay, this is the triangle it looks like we're going to be working with here. So, if we're working with that triangle, and that angle is 18 degrees, that's outside of our triangle. There's some rules we can use to try to figure out some angles inside the triangle. First of all, what type of triangle is this green one we've highlighted?
Right angle.
Yeah, so we do know one angle, right? And we know one side. We need a little more information to solve x. I need to find at least one more angle. Can I use this 18 degrees to figure out one of these two angles here?
Yeah.
Which one? Top?
Yeah.
Okay. How can I use it to figure that out?
Yeah.
Sure. Okay. Now, first of all, there's two types of things we're going to show you here. Okay. First one I'm going to use is, imagine this. Because this line here, at the top, this horizontal one we've drawn, it's parallel to this. Okay. And the lighthouse, we already know, is perpendicular to these two lines, right? It forms a right angle here. So what kind of angles are going to form with this line up here?
Right angle.
Yeah, it's going to form another right angle, okay? So, let's think of this idea. I'll draw it a little bigger. If this forms a right angle, and that's 90 degrees, okay, and we know that part of it is 18, how can I find the rest of this angle? We'll do it in green. If the entire angle is 90, and we know this part's 18, the green part here.
Oh, minus it.
Yeah, there we go. We can subtract it. So we take 90 and subtract what number?
18.
18. So what are we going to get here?
Like 72.
Yeah, exactly. 72 degrees. So we now know that this angle in here is 72 degrees. Now, I'm going to show you another trick. Remember, we knew that these were parallel lines, right? This guy and this guy. Remember alternating angles in grade 9 at all? This makes a Z pattern from here to here and here. In a Z pattern, what does this mean? This angle and this angle, how are they related?
Equal to 180?
Not quite. They're both equal. Yeah. So this means this angle here is how large? If this one's 18,
18 also.
it's 18 also. All right, and let's just double check everything we've said here. We've said the one up here is 72. I know it's a little crowded, so I'm going to redraw this triangle. Okay, so these are the claims we're making right now. We're claiming, okay, using all the information we have, we're claiming that the angle at the top here is 72 degrees. The angle down here we claim is 18. And we said that it's a right angle triangle. This height is 25. And we're looking for this side, right? What do all the angles in a triangle got to add up to? 180. So let's make sure. We have one that's 90, another one that's 72, and another one that's 18. What's that add up to? 180. So, perfect. We use two different methods to figure out the other angles in this, okay? This is a tough question because they talked about an angle of depression. This angle actually wasn't part of the triangle. So we had to use some rules we knew from before to solve the other two. Now that we have all this information, we have more than enough information to solve this triangle. Okay? So because we have more than enough information, let's go ahead and try to solve it. In fact, we're going to solve it two different ways. Okay? First of all, let's say we're dealing with the angle that's 72. X is considered what? Opposite, adjacent, or hypotenuse of that? Opposite. Which means 25 is what? Adjacent or hypotenuse? Adjacent. Good. So opposite and adjacent, what kind of ratio are we using?
25 over x.
Yeah. But which of the three? Sine, cos, or tan? That's right. So tangent, 72, right? You know what? I'm going to do it in, I'm not sure why I chose that color. I'm going to do it in green just so we can try to keep everything in order here. Okay. So tangent, I'll do it on green here. Opposite and adjacent. So tangent 72 is equal to opposite side is x, and the adjacent is 25. Okay? Now I just want to show you that it does not matter what side we decide to use. I've got to change that. Let's say we use the 18. Okay? According to the 18, 25 is what? In reference to 18. Hypotenuse, opposite, or adjacent? So the side 25, in reference to this angle here, 18, it's opposite. Good. And the x is what? Adjacent or hypotenuse? Adjacent. So what ratio again would we use? Same thing, tangent. But we set it up a little different, right? Tangent 18, what's my opposite side here? 25. And what's my adjacent side? X. So let's take a look at these, okay? Do you notice these fractions are reciprocals?
Yeah.
They're flipped. And we have two different terms of degrees.
So we really don't have to do one of them? Or what?
We only have to do one. But I'm going to show you that it doesn't matter which one we chose. We're still going to end up with the same answer, okay? Now, one is going to be a little more work than the other, okay? And I'll show you that. Put this down here. So, first of all, of course, we're always trying to isolate for what?
X.
X. We're always trying to isolate for x. So in the green one, I got to move what to the other side of the equation?
X. You have to isolate x.
So you got to isolate x, so what do I got to move to the other side? Yeah. And when I move it to the other side, what does it become? What operation do I use? Add, subtract, divide, multiply. Multiply. Good. So 25 times tangent 72 equals x. Okay? Now in this one, the x is on the bottom. So what's the first thing I got to do? I I want to get rid of my fraction, right?
Right.
So what do I got to move to the other side? Yeah. Right? And when I move over here, what operation do we use to move it?
Division.
Well,
Sorry.
yeah, same as the other side, right? So now we have x times tangent 18 equals 25. Now, I'm going to keep isolating our x. On this side, x is already isolated. Wonderful. In our red version, is x isolated yet?
Not yet.
No. What do I got to do to isolate it?
Divide 25 by 10.
Great. So I'm going to get x is now equal to 25 divided by tangent 18. Very good. We have to move tangent 18 to the other side of the equation. Okay. So now we're much closer. We're going to do both these operations and see what answer we get. Okay. So tan 72. Let's clear this. 72 tan times 25. 76.94. Okay. 76.94. And meters. Okay. In our other one, because of my calculator, I can't quite do it in one step. Well, I can, but it's a little confusing. I'm going to just figure out what tan 18 is, and I'm going to show you what rounding can do to a question, okay? 18 tangent, oops, wrong button. 18 tangent, 0.3249, okay? 0.3249 equals, now this is our x is equal to, okay? So now 25 divided by that number gives, what's the number again? 3249. So 0.3249 gives us 76.49. So because we went to 4 decimal places, 76.4, oh, sorry, 94, I'm saying that backwards. Okay. If you take a look, our values of x, in both of these, we said x was equal to 76.94. So it didn't matter which of the sides we used, we still got the same answer. Now, clearly, this one was a lot more work, right?
Yeah.
If I realize that if I set this one up, it's much faster to find the answer. But that's part of the process. What I want you to realize is it doesn't matter what side we use, as long as we set it up right, we'll still find the distance of the lighthouse from the boat. It was a difficult question to set up because we're talking about an angle of depression, okay? Okay, so question 112 is a similar triangle question. And you pointed out, first of all, there are 2 triangles, right? We clearly have a green triangle here. Okay. And then, unfortunately, I can't do it. The green trumps the yellow, I think, when I go across. Yeah. But there's our yellow triangle, and they're both similar triangles, okay? That means the angles in them are the same. Okay, so all of these angles here, they're all the same. Now, like you said, first of all, in our green triangle in itself, I can use Pythagorean's theorems to solve what side, did you say?
EC.
EC, that's right. Okay. So, our right angle here, we got side EC with our green triangle. Okay? So, we'll put this over here. So, we're going to use Pythagorean's theorem. This is 4 meters. This is 6 meters. Using that theorem, how do we solve this? What side are we looking for, first of all? What would that be considered?
Yeah, EC.
Yeah, EC. There's also a name for it. Usually,
C squared.
okay, yeah, C squared, which is the hypotenuse. Good. So that will be our C squared is equal to A squared plus B squared. Now the C squared has always got to be the hypotenuse, right? So that's really our x. So we're going to replace C with x. And we get x squared is equal to 4 squared plus 6 squared, right? So let's quickly go through this here.
16 plus 36.
Yeah.
50. Oh, sorry. 52.
There we go. 52. Great. And then, what do I got to do to figure out what x is? Are we done? Is that how far x is? 52? One more operation I got to do. Because this says x squared.
Oh, you have to divide.
Not divide, but
You do.
square root. Yeah. So we got to find the square root. So x is equal to, let's put that 52 square root, 7.21, let's say, okay? 7.21. So what we just figured out is this part here, from here to here, 7.21 in terms of its length. Okay, so we have that. Now, this is still a similar triangle question. So we've solved this part, but it still hasn't really gotten us how far he is away from the base of the building. That's what the goal of this question, right? They want to know how far BC was. We'll call that our, we'll call it Z, okay, as our variable. We're trying to find that total distance there. So we have similar triangles. With similar triangles, what we're going to try to do is we're going to try to set up all the sides here. Okay, so I'm going to also draw, and it won't be to scale, the yellow triangle just underneath with the measurements that we have. So this is our yellow triangle. Now the only information they gave us about the yellow triangle is that this is 150. Okay, we actually don't know anything else. We do actually know that part of it, let's say to there, to here, is how far? The same as this idea here. 6. We know that we have like 6 meters here. Okay. Our goal is to find out what Z is. That's the whole point of this.
Z?
Well, we called it Z from B to C.
Oh, sorry.
Right? That's fine. We'll call it from B to C, and this was, I think, A. Right? B to C. Yeah. Okay.
How do you figure it out?
Yeah. So this one is a bit confusing, right? There's several ways we can do this. First of all, and let's put this one up here. This is 7.21. We now have all the sides of this triangle. Okay, so we can do a lot of detective work. With these sides, I can start solving for angles. Okay, and because it's a similar triangle, the angles will be the same. Then I'll start having sides and angles, and I can use some of these ratios. But there's a lot of work because what I'm going to have to use is I'm going to have to use cosine law to start figuring out these angles, which is it's a big formula. It takes quite a bit of work. Another way we can set this up is talk about similar sides in the triangle. Okay, so in reference to each other, this is point F. Okay, EC is a reference to AC in our similar triangles, right? This would be the similar side of this. Okay, they're definitely going to be different lengths, but those are the sides that correspond to each other. Side FC corresponds to side BC. Okay, same idea. This is our FC, this is our BC. They correspond to each other. And finally, the ratio of EF corresponds to AB. Okay, so what we did, if you look at this, we put all of the sides of the green triangle on top, and we put their corresponding yellow triangle or larger triangle on the bottom. Okay, we set up like a fraction, ratios. So I'm going to replace the information I have on all of these. So EC, right off the bat, EC is 7.21. We know that. 7.21 divided by, do we know the distance of AC? So let's just call it AC. FC is how far? 6. Do we know how far BC is? No. That's what, essentially, we're trying to find that, right? That's our goal here. And finally, EF. 4. Do we know how far AB is? Oops, not the right AB. So we do have one of the ratios, kind of like in sine law, right? We need to set up a ratio. So this is 150. So we have a ratio here. What we're going to look for, and what they usually call is like a K factor. And what they mean by that is I got to figure out what I multiply 4 by, we'll call it K, to get to 150. Okay, it's just like multiplying across, because what that means is I can multiply 7.21 by this K factor, and that'll tell me AC, or I can multiply 6 by this K factor, we'll say multiplied by, right? This is our goal, and it will tell me what BC is. So because I have this ratio, I can set this up like a question. I have 4 multiplied by, and we're going to call this factor the K factor, okay? So 4 multiplied by K gives us 150. Okay, so I got to figure out what k is. What would I do in this process? Isolate for k.
Isolate k, so it would be 150 divided by 4.
Good. So k is equal to 150 divided by 4. Okay, I should write k.
Is that a decimal number?
Well, yeah, for sure it will be. Well, actually, yeah, it's definitely going to be decimal. Want to figure it out? Type in that calculator.
Yes, 37 decimal 5.
Sorry, was it?
37.
Decimal 5?
Yeah.
Oh, nice. That's not that bad of a number. So k is 37.5. What's our goal? What are we trying to find?
BC.
BC. So we're trying to find BC, so let's not really worry about this ratio here. Let's talk about this. We know what our k factor is, and we know our number we started with was 6. So let's go 6 times our k factor. K factor is 37.5. Okay, is equal to BC. Let's type that in. 6 times 37.5 gives us 225. So side BC is equal to 225. I think it's meters up at the top.
Where would you get the number, the letter k from?
K is our scale factor. Okay, this is something we have to know with similar triangles. Is what it means is this triangle, because all the angles are the same, this green triangle, is the same as this yellow triangle. I just have to multiply its distances by a certain number. We call that number k. Okay, so if I multiply 7.21 here by that k, which in this case was 37.5, it'll give me the distance of AC. What we're saying is the yellow triangle is 37.5 times bigger than the green triangle. Okay, so if the angles are the same, we just got to figure out what number we multiply by, and you can make the triangle as big as you want. Okay, there's just some k, or a scale factor we call it, that we have to figure out what to multiply by.